In this question, it says that the equations of line L and M are given by these two equations, where C is a positive constant. It is given that the angle between L and M is 60°. Find the value of C. All right, so if the angle is 60°, we're going to write cos 60 equals to direction vector of both of these. This one is 1, 1, 2 dot. This direction vector is -2, 4, and C. Okay, sorry about that. Okay, so the other direction vector is -2, 4, C. And in the denominator, we take the magnitudes of these vectors. The first magnitude is 1 square plus 1 square plus 2 square. That's going to be a 6. And the other magnitude would be 2 square 4 plus 4 square 16. So that would be a 20 plus C squared. Okay. Now we're going to use the dot product in the numerator. So we get a cos 60 equals -2 plus 4 plus 2C. So that's 2 plus 2C. And you may take square root common or you may not, does not make any difference. If I take square root common, I get a 120 plus 6C squared. Okay, now what is cos 60? Cos 60 is a half, so I'm going to replace this with a half. And I'm going to cross multiply and then square both sides. So we get 120 plus 6C squared equals 4 plus 4C. Square both sides. 120 plus 6C squared equals, apply the quadratic formula. Apply the identity a square plus 2ab plus b square. So 16 plus 32c plus 16c squared. Rearrange, get a quadratic equation. 0 equals 10c squared plus 32c minus 104. Okay, we may apply the quadratic formula here. Minus b plus minus b squared, which is b squared minus 4 times a times c upon 2a. So solve this in the calculator. We'll get c is equals to 2 and c equals -26 over 5. But it says that c is a positive constant. So we may only write this as our final answer. We will only write this as a final answer. Okay. Part B says, show that the length of perpendicular from this point to the line L is under root 11. All right, let's do that. So the point is, let's call it P, 6, comma, -3, comma, 6. And the line is the line L, and we already have its equation. L is R equals 3 minus 2, 1 plus lambda 1, 1, 2. Okay. And we need to find this length, this perpendicular length. Okay, so I'm marking this foot of perpendicular as X. So first step is you write down the position vector of P and the point of intersection. So P is 6, OP is 6 minus 3, 6, and OX is 3 plus lambda minus 2 plus lambda and 1 plus 2 lambda. Okay, next you have to find the vector Px, which is Ox minus OP. So subtract these two. 3 plus lambda minus 6 would be -3 plus lambda. Minus 2 plus lambda minus minus 3 would be 1 plus lambda. And 1 plus 2 lambda minus 6 would be minus 5 plus 2 lambda. Okay. Now we have this vector px, and this is a direction which is parallel to the yellow line. So it's some direction like this. And notice that this direction and the vector px, they're also perpendicular. So their dot product must be equals to 0. So sorry if you can hear that in the background. There seems to be some construction going on in the neighborhood. Okay, so px dot ax is equals to 0. It's going to be minus 3 plus lambda, 1 plus lambda, minus 5 plus 2 lambda. Sorry, not ox, but its direction. 1, 1, 2. Okay, so dot 1, 1, 2 must be equals to 0. We're going to solve this and get the value of lambda. So we get minus 3 plus lambda times 1, which is this. Then 1 plus lambda times 1, which is plus 1 plus lambda. Then plus 2 times bracket minus 5 plus 2 lambda. That would be minus 10 plus 4 lambda equals to 0. Solve this, you will get lambda is equals to 2. Now we substitute that in the vector px to get the exact coordinates. Okay, so we get a negative 1, we get a 3, and we get a negative 1 again. And we have to find the exact length. That means we find its magnitude, which is going to be square root of negative 1 whole squared plus 3 squared plus negative 1 whole squared. So that's going to be 1 plus 9 plus 1, which is square root of 11.